What we're going to review today is this UNI-T UT8805E professional grade benchtop multimeter, which features 5.5 digits or 200,000 count resolution. And it's loaded with modern functionality. I'm gonna say this right from the start. Such gear is probably overkill for basic hobby projects, but very much needed if you're doing any kind of professional work, or even at hobby level if you're doing anything which requires higher precision and resolution. And I can already see the comments left below that you can get an HP or edge length meter like the 3478A, which would also be a 5.5 digit meter with similar specs, but that meter was made 20 to 30 years ago, so apart from the resolution and precision, you would be getting none of the modern features, connectivity or warranty that you would get with a new meter like this one. So 10-15 years ago, we didn't have affordable good options that would compare with meters that were designed 20 to 30 years ago. So it was a good option to try and source one of those. But today we have these options. They have the same resolution accuracy, but they come loaded with many newer features that improve your workflow, and they sell for affordable prices. So in my opinion, I would strongly consider a new meter versus one that's 20-year-old today, just because there are better, newer alternatives on the market. Unless you want to collect them because you love old gear, well, at that point, you're probably going to buy old and new at the same time. So this meter comes with a 4.3 inch 480 by 272 TFT LCD. It can do up to 5K readings per second. Its true RMS has 1 GB of internal flash storage, and if we take a look at the specified accuracy in its datasheet, it's quite impressive. For the 1 year column, we mostly get 0.015% plus a few counts for DC voltage, and I'll link in the datasheet below so you can check out the full specs. Now, apart from the standard measurements that you would expect from it, it can also do diode testing up to 4 volts, frequency measurement in the range of 20 Hz to 1 MHz, duty cycle measurements 1 microsecond to 0.05 seconds, thermocouple and thermal resistance sensor temperature measurement with built-in cold junction compensation, and it has various math functions as well as histogram, trend charts, bar charts, and we'll look at all of those in a second. In terms of connectivity, we get USB host on the front, and then moving to the back panel, we get the IEC mains input with a fuse and on-off switch, as well as a voltage selector switch. We get RS-232 via DB9 connector, Ethernet. There is an option for GPIB, which is missing from my unit, but the user manual specifies it. We get USB device. We get external trigger, we get VMC voltage measurement complete output, and the fuse for the current measurement. Form factor and general design is very similar to the one we saw in the UNI-T power supply review, except that this one comes with this handle, which is removable, and I'm also probably going to remove both the handle and these rubber bumpers because they will get in my way here on the workbench where my real estate is limited. But after removing these, it should fit quite nicely stacked on top of the power supply unit, for example. The meter was very nicely packed inside a double box. It was protected and suspended in foam blocks, and inside the box you will receive a mains IEC cable according to your shipping location, a set of multimeter test leads which feel decent, and they seem to have silicone insulation which is rated for 150 degrees Celsius. You'll also be getting a set of these short alligator test leads, a USB type B to USB type A cable, a DB9 serial connection cable, a K-type thermocouple, and very importantly, you'll also be getting one of these, a certificate of calibration, which shows that this unit with this particular serial number was tested against these test instruments, and it obtained these results for checking on the various measurements. Plugging in power and turning on the main switch on the back puts the meter in standby mode, and you get a red indicator light on the front panel on this soft power on switch. I very much like this feature, and I wish I would have the same on the power supply unit, which just has a hard power on switch with no standby power indicator. To me, this is useful because it lets me know here at the workbench, just at a glance, that I have power turned on at my workbench. Upon turning on the unit, you'll be greeted with the UNI-T logo and an unexpected annoying fan noise, and I'm struggling to understand why they need a fan running at this speed on a multimeter. It is noticeably noisier than the power supply unit I recently reviewed. We'll have to check this in the teardown later on. Here's a sample of the noise. On the plus side, the meter does boot up really fast, which is something that I always appreciate. Display is quite nice and crisp with plenty of brightness, and I quite like what they did here with the white font on black background, making it very visible even from a distance. And let me just remove the protective film from the screen. Front panel interface shows that the meter is rated for Cat2 300 volts, which is a fairly typical rating for benchtop multimeters. We get the usual 4-wire measurement input terminal arrangement with separate high current measurement jack rated for up to 10 amps. I don't think there is any insertion detection for the input terminals, so if you plug in to the current terminal while in voltage measurement, it cannot detect that. That's a function that I would certainly like to see on such a bench multimeter. And I should also mention that there is no back terminal sensing, which is sometimes used when integrating instruments into test and validation racks. Something that's always impressive with a modern multimeter like this one is the high update rate, and we can easily check that by switching the speed option. For example, we can go to medium, and we can already see there's more updates per second, and if we switch that to fast, it's crazy fast. Now what we'll notice here is that it's quite a big offset on this DC voltage measurement, and by default the meter powers on with the input impedance set to auto, which for DC voltage measurement allows you to automatically switch between 10 megaohm or 10 gigaohm for scales of 200 millivolts, 2 volts and 20 volts. So I believe that if we switch this to 10 megohm, yeah, it brings that offset down to just a few tenths of millivolts. The general graphical user interface is very intuitive. There's no need to read the user manual to understand how to use this equipment. We get function buttons at the bottom of the screen, so these will adjust depending on which measurement you have selected and which screen you're on. So for DC voltage, for example, we can adjust the range, the update speed, the input impedance, or the relative function can be turned on here. And we can also have access to the history page, which will give you like this list view of the measurements that you did. The top bar will show you the actual measurement you're on, the scale, the trigger, because we do get this trigger functionality similar to an oscilloscope, and you can output that trigger signal on the back panel and do other stuff with it. From the keypad we can select the measurement type, and there are primary functions, which are the ones written on the key itself, and then there are secondary functions which you activate with the shift key, and those are the ones printed on the actual front panel. So we have DC voltage and current, we have AC voltage and current, we have resistance measurement in 2-wire or 4-wire mode, we have capacitance measurement and temperature measurement, we have continuity and diode, we have frequency and period, and then these are keys that trigger the various other functions of the instrument. Now let's check the utility menu. So shift and this key will open up the utility menu at the bottom, and from here we can adjust various stuff. We can go into system, where we can adjust the language, we can turn on or off the buzzer, we can adjust the display brightness. Format, I think this has something to do with the export of data, because we can select comma or space, so I'm assuming that's the separator between the various fields in the data collection. The About menu shows that I'm running version 1.82, and on UNI-T's website they're offering for download version 1.87, so I've copied that to a flash drive. You have to unzip the archive and have just the files in the root of your flash drive. I've inserted the stick on the front panel port, and then I went into Utility, Upgrade, Locate, and then I selected the upgrade file from the flash drive. Now the upgrade appeared to have started, but no progress was shown, and I tried to be patient and left it there for 30 minutes, at which point it was pretty clear that something was not right. And then I tried pressing a few buttons with no result. I then just removed the USB drive and restarted the meter, and it showed this message asking for the USB drive. And then I inserted the drive, and now it started showing some progress, after which it switched to the UNI-T logo, and again it was stuck there. I waited a couple of minutes, after which I removed the USB drive, and the meter immediately booted into the new firmware version. Now going into the utility menu shows that I'm now running the new version 1.87, so I just used the reset to default settings option just for good measure. I would say the update procedure is very sketchy and it should be improved for an instrument of this class. I will be sending this feedback to UNI-T so that they can hopefully fix this in future revisions. Now let's try the continuity tester using the supplied test probes, which by the way are quite nice. These must be the nicest UNI-T probes that I have seen so far, and like I mentioned in the beginning, they do have silicone insulation. So the continuity tester is working, but here's something interesting. Even though I have the beeper turned on, there is no beeper actually on the continuity function. So I don't know, could this be a bug? Maybe. It could also be a hardware problem, like the buzzer actually being defective. I'm gonna send an email to UNI-T and check with them, because I'm already running the latest firmware. I also have the global setting for the buzzer, which is here under system, and I also have this one turned on, and still no beep. And one nice feature that I can mention about the continuity tester is that you can set a threshold in ohms, and it would only detect a continuity once the value goes below the threshold you set here. So the impedance you can set here can range from 0 to 2K according to the user manual. So this could be useful, I'm guessing, in some cases where you know you're expecting a specific impedance. However, I would prefer to have the beeper function, which is of course super useful on a multimeter. It's a very basic feature, so I would prefer to have that working. In terms of checking the absolute accuracy of this meter, I am not a volt nut. I do not own high precision references. I do have a few here which are decent, so I'll only be checking basic accuracy and comparing against my Agilent 3441A, which is a 6.5 digit instrument, and it's the best instrument I have in the lab. Let's start with this resistance standard built with V-shape foil resistor, and I showed how I built this in a previous video. The people from V-shape high precision group were nice enough to provide me with some very fancy high accuracy measurements of the resistors that they've also supplied, and these measurements were done on a 7.5 digit multimeter. So I have the results of those measurements here, and we're going to be measuring using the 4-wire measurements, and I have a 1K, 10K and 100K resistor inside this box. Now pay close attention to how UNI-T specifies their accuracy in the datasheet. It's given as a plus or minus percentage of the reading plus a percentage of the range you're on. So I've calculated as such, and all of the measurements I did with the resistance standard fall within the advertised accuracy figure. Now let's continue with this current standard, which should be 0.15% accurate. That's insufficient for checking this instrument that has an order of magnitude better accuracy, and I'm only getting 3 values from this current reference. It can do 1000 microamps, 100 microamps and 10 microamps. I've added the maximum allowed error here in this table for easy reference, and I've calculated this using the datasheet accuracy formula of percent reading plus percent of the range. And for the 1000 microamps we're good. However, for the 100 microamps, it would seem that we are outside the claimed accuracy, but it is in fact a problem with the measurement setup, because due to the resolution of the Agilent 34401, we're getting less digit on its measurement, so this results in a higher error if we're considering that a good known reference against the UNI-T. So it's not a problem with the UNI-T, which has more digits, but with the Agilent. The 10 microamp measurement appears to be right at the limit, but again, a limitation because of the fewer digits we get from the Agilent. For testing the voltage accuracy, I have this AD584LH voltage reference, which can output several different voltages, each with its own accuracy. And this time, the meter accuracy of 0.01% on the 20 volt range is pretty close to what our voltage standard can do in theory. So I have added this first column showing voltage reference specs for the various outputs. This is taken from the AD584LH datasheet. And now for this test, the results are stellar, with both the Agilent and the UNI-T agreeing very closely to the last digit. So after performing all of these tests, I would say I'm fairly confident the meter accuracy is within spec, but in lack of higher precision references, I don't have enough actual data to back that up for the volt nuts out there. Now let me show you a couple more interesting features that this meter offers. For example, it has this dual display mode where you can have a primary measurement and a secondary one, and there is a specific set of measurements that you can combine, and the user manual does provide details on this as well as the limitations that apply. So you can have, for example, AC voltage with secondary frequency measurement, AC current with frequency, frequency with period, or the other way around, temperature with voltage, or temperature with resistance. So for example, right now I have an AC input generated from the UTG962E arbitrary waveform generator. It's a 1 kHz 2 volts peak-to-peak AC signal, so the meter can show both the AC voltage and the frequency. The temperature measurement mode is quite comprehensive because it supports all of the popular types of thermocouples, B, E, J, K, N, R, S, T, and additionally it supports RTD type sensors in 2-wire or 4-wire mode. It supports thermistors in 2-wire or 4-wire modes. It can support RTD type temperature sensors like ITS-90, PT100 and PT385, and all of these with cold junction compensation, which is integrated into the meter. And as we can see here with the included thermocouple, we do get all of these options, and you also get an offset adjustment option as well as the ability to switch the measurement units from degrees Celsius to Fahrenheit or Kelvin. So like I said, it's probably the most comprehensive temperature measurement function that I've seen in a multimeter. By pressing the math button, we can activate things like statistics, and we'll get these values like mean, max, average, standard deviation, which are all very nice to have in a modern multimeter. And you can clear the accumulated samples to have it go back to 0. You can set a high and a low threshold, and this would help, I'm assuming, with issuing the trigger signal on the back of the meter, or by triggering the buzzer, which in my case it's not working. Then we can also adjust the way these things are displayed. So the default is number, it's what we've seen so far, but we can also select a trend, a bar graph, or a histogram. There is various functionality and settings with each one of these modes, but I won't go into too many details with these, because while it's nice to have them on the meter, I would probably just do data logging and analyze my data on a computer anyway. Now let's go over the connectivity options and the PC app. And like I mentioned in the beginning of the video, we do have USB, serial, Ethernet, as well as an option for GPIB, which my particular unit doesn't have. I'm a big fan of Ethernet connectivity. I've recently installed a gigabit Ethernet switch at my workbench. So now I have the capability to connect all of my test equipment to my local network. After connecting an RJ45, we can check the utility I/O menu to make sure we have DHCP turned on. Then the instrument will get an IP address assigned from DHCP. And unlike the UNI-T power supply, which I reviewed recently that supported Skippy over Ethernet, this multimeter supports Skippy over Ethernet, but also adds LXI support on top of that, which in theory should offer a web view control capability. But when you put in the IP address of the meter in a browser, you'll just be getting this generic info page and the ability to set the IP address. There's no web view or control of the instrument implemented, which would have been really nice to have. But LXI is a good thing. For example, you can make use of the OpenLXI tools, which would give you control over the instrument through open source tools, and you can automate all sorts of things and do advanced data logging and testing. Now, I haven't actually tried LXI tools with this multimeter, but I will put a link in the description to the LXI tools project on GitHub. The Windows-only PC app that UNI-T provides can be downloaded from their website on the product page under software. It is based on the annoying NY Visa runtime, but because I already had that installed from the PSU video, this time it was much quicker to set up. Unfortunately, when I tried to connect via LAN using the correct IP address, it fails every single time. I have tried restarting the instrument, checking the IP address. It's all correct, it's alive. It's just that the software doesn't connect via LAN. So I switched to using USB and it connected. It started logging measurements right away. It started showing a graph. I can select a different measurement, but if I select the math function and I want to enable statistics, it just shows them on the multimeter itself, not in the app. I can save the data it logged in an XLS format. So at least some of the basic functionality works, but generally the app feels very outdated, clumsy, it locks up sometimes. Just the functionality that it provides is, in my opinion, not up to modern standards. I think you might have better results by using some open source tools like LXI tools, which I mentioned earlier. And the fact that their own released tools cannot connect over LAN to their instrument is pretty disappointing. So after playing with this multimeter for the past couple of weeks, I think I'm ready to provide some objective feedback, and I'm gonna start with the bad stuff first. It's annoying that we don't get a web view or web control interface like any modern instrument should have. It makes my life so much easier having that because I don't have to install software. I just go to an IP address and I can control, view, or take screenshots of the instrument via web. Now the update procedure, as you've seen, is pretty bad. I think it could be improved a lot to make the user experience nicer. There's nothing worse than being stuck in the update procedure like I was, not knowing if it failed or if it's still actually doing something under the hood. The buzzer doesn't appear to be working on my unit, which is strange. This was a new out of the factory unit. I will email UNI-T to report these problems and we'll see what they recommend. I'm not sure if this is a problem in the firmware or in the hardware. The PC app is buggy, doesn't connect via LAN, and generally is very limited in functionality with this outdated look and feel. If you're not going to offer me a web interface and you're not offering a good PC app, then this limits the potential use of the instrument for a bunch of users that had this planned. The cooling fan noise is annoying. Why did they have to put such a noisy cooling fan on a multimeter? It doesn't make sense. A multimeter is something that you can leave turned on for many hours. It shouldn't be annoying. But there are also good things to be said about the instrument. The build quality is very good, and we'll see more about this in a future video where I do the teardown. The user interface is decent. Certainly you don't need a manual to learn how to use it. It's all very intuitive and gets the job done, and that's all I need. The screen is bright and crisp, can be read from a distance. Accuracy is good as shown from my tests, and there are plenty of available measurement types and functionality built into this meter, and I would very much prefer to use this meter with its modern user interface than one of my old HP or Agilent meters. Even with its limitation, I would still prefer to use this one. There are plenty of connectivity options on this thing: serial, USB, Ethernet, and optionally GPIB. There is even internal memory, which can be used as storage for data logging. and the included accessories are pretty nice and very useful. You get cables for connectivity, you get the thermocouple, you get nice silicone test leads, you get the short alligator clips. And my final opinion is that it certainly makes sense to order such a meter if the bugs are fixed, because at that point it is slightly better positioned on the market, offering more functionality than its competitors in this form factor, which are selling for a very similar price. So I'll try to keep you updated on this. I'll send these problems to UNI-T and we'll see how they address them. In the meantime, if you'd like to check out the pricing on this, I'll put a link below to some shops where you can find this meter. And I would also love to hear from you in the comments below whether you already own a comparable modern bench multimeter, if you're happy with it, or if you would prefer a 20 to 30-year-old meter with less functionality. Give me some arguments in the comments below. That was all for today. Make sure to subscribe to the channel for more content ahead. There will be a teardown video. Thank you for joining me, and I'll catch you in the next video.